Hello, we're going to solder the connection pins to the DF robot module. And the first thing that you need is a brass sponge to clean the tip of your soldering iron. And the next thing that you're going to need is some solder. And this happens to be 0.6 millimeter and it's lead-free solder. Next is some soldering flux. This is used to remove any oxidization or dirt on some of the materials that you'll be soldering, the pins and the pads of the device. The next item that you'll need is a soldering iron, and this is the one that was handed out with your kit. It's a 30-watt soldering iron. Okay, make sure your tip is clean, and when you're done soldering, make sure you add a little bit of solder to the tip of the iron. Use a wet sponge to clean the tip of the soldering iron. It makes soldering much easier. Here we're using the Arduino I/O board just as a way to solder the module. Makes it a little easier to keep the pins vertical. Notice there are 2 holes at the top and 2 holes at the bottom that are free. Here I'm applying a little bit of solder flux so that I have clean joints when I actually do the soldering. Now I'm cleaning the tip of my soldering iron. I'm going to apply a little bit of solder to the tip. Okay, and you notice that the smoke is being sucked up by the fume hood. I'm going to apply a little bit more solder to the tip. Place the soldering iron on the tip and the pad, and then a little bit of solder, and then take the soldering iron away. That one I maybe took it away a little bit too soon, but let's try again with a second one. So the soldering iron on the pad and the pin, and then apply the solder. Probably I should be leaving the soldering iron on the pad a little longer. We're going to do one more pin. Okay. And then heat up the pad and the pin, and then a little bit of solder to the pad and the pin. We need a little bit more solder on the iron, and then eventually back onto the pad and the pin, heating both up simultaneously, adding a little bit of solder to the pad and to the pin. And there we go. Now I'm going to flip the board around so I can do the other pins. I've already soldered one of the pins, but I need to do 5 more. So I want to make sure that my soldering iron tip is clean. Then I'm going to add a little bit of solder to the tip. Okay, now place the iron onto the pad and the pin. And again, I should be leaving the soldering iron a little longer, but let's try some of the other pins. All right, next pin. And this is how quickly it can be done, but keeping that tip clean again. Moving over to the brass pad and the wet sponge. A little bit of solder onto the tip, iron onto the pad, and then the solder onto the pin and the iron. Okay, and this is working out quite well. Notice I put a little bit of solder because that solder is going to help conduct the heat to the pin and the pad. And one more to go, and then we're done. Okay. And so you notice I'm using the soldering iron to heat the pin and the pad. There we go. I think all 12 pins are done now. So here is the final soldering product, and all 12 pins are soldered. And if I look at it on the side view, fairly clean joint for all 12 pins, and they're vertical, so it should fit into the proto board quite well. And on the back are some capacitors for across the motors and the TB6612 motor controller IC. This is the power supply section and the motor control modules for the robot used in the lab class. This top bus is used for the plus 5 volt signal. These 2 buses are the ground bus, should be common with the Arduino ground. This final bus is for the 8-volt supply. Use yellow wire for this bus. This is the 1.3 amp fuse, and it protects the circuit connected in series with the battery or power supply. The first 4 switches in the image control the voltage to different points in the circuit. First of all, on the left-hand side, this supplies the 8 volts to the bus below. The next switch over is to supply 5 volts to the top bus. And the third one is to supply 8 volts to the V-in signal. It does go through a diode first, and that protects the Arduino from a reverse voltage. The 5-volt regulator controls the voltage out, and the input is 8 volts, and it brings the output down to 5 volts. And that eventually connects to the 5-volt bus on the top rail through a 250 milliamp fuse. Okay, let's have a look at different parts of the circuit for the robot power supply and motor controllers. Let's start off with each of the 4 buses. There are 2 ground buses down here and up here. And when you build your circuit, make sure your ground bus is down at the bottom. The bus just above the ground here represents the 8 volts. Up here, the 5 volts. And controlling all of these buses, we start off by either the input coming from the battery or the power supply. For lab 2, it'll be the power supply. It then goes through this 1.5 amp fuse, comes out of here, and gets distributed to the inputs of these 3 switches. One to supply power to the 5-volt bus, to the 8-volt bus down here. The second one goes through this switch, and when it's closed, the yellow wire goes to the input of the voltage regulator, and the output is at 5 volts. And then finally, the third switch goes to V-in on the Arduino. So it goes through this diode. The cathode is on this side, and then you have to connect a wire from the cathode to the V-in on the Arduino. And the Arduino also has to be connected to ground using the upper or lower ground bus. The next point we'll look at are is the regulator. The regulator's here. So it's kind of shown from the back. So the out and in are the opposite. The input is on the right, the output's on the left. These 2 capacitors filter input and output noise. They connect to ground on one side. And then the output of the regulator is on this side here, goes through this fuse, 250 milliamps, and then to the 5-volt bus. So for the 5-volt bus to work, you have to have this switch closed, and that fuse has to be working. Over here are the 2 DF Robotics modules, and they're controlled with a TB6612 IC on the back of the module. And we'll be powering this up with 8 volts. So the V of the motor has to be connected on this pin, and you'll see each of these 2 pins has that. And it needs to be supplied with 5 volts to control the logic signals inside that device. And then each motor, and these 2 points are where the motors connect to, here and here, for motor 2, motor 1, same thing over here. And then the control signals are only direction and pulse width modulation, and both of those signals are pulled low internally. So this is where we'll connect a pulse width modulation signal for motor 1 and motor 2 coming from 2 different pins on the Arduino, and same thing for the other side over here. So that's where we'll be kind of headed with the power supply and the motor controller. This is a view from the opposite direction. So now we're looking at the front of the regulator, and the left-hand side is the input. The right-hand side is the output going to the bus with a 250 milliamp fuse. The other thing this view shows you better is that this switch here supplies the 8 volts to the anode of the diode. The cathode is up here. That cathode goes into this hole, and then that's where we connect the V into on the Arduino. This is what will supply power to the Arduino when we're operating the robot on the floor. The other connection that you have to make is to ground through this bus and then to this pin on the Arduino. Notice as well that there's a bus for each of those voltages. There's a ground on the top and bottom of this board. The 8 volts is on this side, the 5 volts is on this side. And the connection for ground between both ends happens here. So there's a connection to ground, goes to the ground of the regulator, and on the other side, that ground connects to this bus up here. And these are the two motor control modules. It's actually controlled by a chip called the TB6612, which is underneath this device. These two things here are LEDs to indicate that there's power, and I believe it's coming from the 8 volts. This is the schematic for the power supply and for at least one DF robot motor controller. So let's kind of follow through the schematics. So down here is where the power comes in. It can be through the battery or from the power supply. And on the battery, there's actually a switch. And then it goes first through this fuse. This is the bigger fuse. I believe in our case, it's 1.35 amps. Then it's going to one side of the switch. It's being distributed to different points on the switch. And then on the output side, goes to 3 places. Goes to the 8 volt bus, to V in on the Arduino, or to the 5 volt regulator. Let's start off with the 5 volt regulator. So when we close this switch, this wire should be equal to 8 volts. That goes to the input of the regulator. The common goes to ground. The output of the regulator then goes to the I think it's a 250 milliamp fuse, and that goes to the bus to give us the 5 volts on the bus. And the input and the output must be connected to 2 capacitors, this one at 0.33 for the input and 0.11 at the output. So that's kind of the 5 volt supply. The 8 volts comes from this side of the switch, gets distributed to here, goes to 3 different places. It goes to the bus, and then on the bus there'll be a yellow LED that connects through to the ground with a 1K resistor, and it also goes to V motor of the DF robot module, and it'll go to both of them eventually. Okay, so that LED comes on when this switch gets closed. The next path is through V in, which goes to the anode of a diode, and then to V in on the Arduino. And then also the Arduino must be connected to ground. Okay, so that's V in and ground. And then this is the motor control module. It has to connect to 8 volts, VCC, and ground. Both of these grounds are going to be the common ground on the prototyping board, which is the same as the ground on the Arduino. It can control 2 motors. I have one of them connected here. Motor 1 going to positive, motor 1 negative going to the negative of the motor. That motor, this one connected here, is controlled by these 2 pins, direction 1 and pulse width modulation 1. We can test it manually or connect it to the Arduino. We'll do both in lab number 2. And then the second motor control will be here, but we're only testing one in that first lab. Now, be very careful in soldering the module because the device costs, I think, about $7 for each one. And this happens to be, I believe, from DigiKey. And for DigiKey, when you order it, it'd be $7 for each module plus $8 for delivery. So that adds up. Be very careful in not damaging it when you're hooking it up to the prototype board and when you're soldering.